This is a very large, well, what would have been crown or shearing crack, since this isn't steep enough terrain to produce an avalanche. But this is up here at Arctic Valley. So looks like this thing is at least 18 inches deep. It's probably down to the ground on basal weak layers, a hard slab. Like I said, huge crown. Looks like it's close to 100 yards. So this whole thing would have ripped out had this been steep enough. See more big cracks here. Like I said, this whole thing was buckling at one point, probably during last Monday to Tuesday's wind event, which produced the biggest natural avalanche cycle in Chugach State Park in what seems like at least a half a decade. Of note today, there's surface hoar forming on top of this wind board, which ranges from breakable to supportable, and it is also fastening out, becoming less supportable in some areas. However, things seem like they've been stabilizing due to the recent weather. The inversion definitely helped the temperature gradient, and seems like it would have facilitated a benign metamorphism of the snowpack, rounding of the snow grains, and stabilization. So it should be noted over on this north side here, as opposed to the sunnier side of the ridge where we saw all those cracks from that buckling slope, which had a lot of warmth, solar radiation from the inversion earlier this week and last week. That's stabilized. You can tell that the snow's settled significantly, warmed up, and rounded, re-solidified, stabilized. Over here on the north side, a lot different scene. Still all very, very dry snow with no evidence whatsoever of having melted and refrozen. A lot steeper temperature gradient. You can see the faceted stuff, which may be over there. The basal facets and depth core on that sunny side of the ridge where all the cracks were at, but just way softer wind slabs decomposing over here, whereas on the other side, on this north side here, they're about 1 finger hardness at the most, some 4-finger density changes, more like pencil knife hard over on the other side. So here we are at Arctic Valley. Had some daylight left on the way out. Some back over in the vicinity of all those cracks on that buckling slope we saw earlier. I just wanted to compare the snowpack to the one on the other side of the ridge there, the northerly aspect facing the highway. As expected, much different over here. You can see this deeper snowpack, about 85 centimeters, pretty solid slab here. You can see out there scooting it around, it broke a density change, but you got this big solid slab right there. It took a lot to get it to break at that mid-level, otherwise I was jostling it all around and it was just a huge slab. So you have that big hard slab, and then here you got the basal weak layers like on the other side, but probably several inches, very loose stuff there. But you gotta, like I said, pencil. There's that density change where it broke right there. Mainly pencil going down to a 1 finger minus, where that bottom stuff starts faceting, and then 4 finger minus fist loose stuff down here. Again, ECTX on the pit results. Although when I pried it, the whole thing released out pretty on that lower layer. This slab's going to be a lot more supportable, unlike the other side. Seems like you'd be a lot more likely to trigger a slab, persistent slab, largely because the snowpack's thinner and less supportable to bridge the weight of someone on that basal weak layer. But as you can see, the Chugach State Park snowpack variable as always. So what's true right here isn't true right over there where there's no snow. It's about 15 feet away. So one thing I forgot to mention that you can see here on the top is the ECTX hard slab I pulled out on the basal weak layers. You can see this is the surface. There's some surface hoar growing on this like pencil hard windboard. So if that's preserved and buried, especially if it grows any larger, it could be a really dangerous weak layer and bed surface. So here's another one of those crown cracks, knot slide. However, over there, really hard to see in the flat light. See it there right in the center. Looks like this did slide straight ahead where it's steeper. There's a gully right there, hard to see. And the rollover in the flat light, there's some debris there where this persistent slab pulled out likely naturally.